Good morning, student. Yesterday we learned the topic acids and bases. What are acids and what are bases? What are strong acids and weak acids? What are strong base, weak base? And how acid can react with metal and how the base can react with metal. And also some of the common acids that we can use it in our day-to-day life, and what are the common bases that we are using in our day-to-day life. So these are the things we learned yesterday. And today we are going to learn a new topic. How do metal carbonates and metal hydrogen carbonates react with acids? So you all turn to your page number 20 in your given in your book, and there's an activity which is given on that page, activity 2.5. You all can open that book and go to this activity and read this activity. So I just want to summary what is actually given in this activity. They ask you to take two test tubes. In one test tube, you should add sodium carbonate. In another test tube, you should add sodium hydrogen carbonate. And in both test tube, that means the test tube A is filled with sodium carbonate and test tube B is filled with sodium hydrogen carbonate. And sodium carbonate is nothing but the washing soda, okay? And sodium hydrogen carbonate is nothing but baking soda. You can also try it in your home, but be safe. Okay, what you should do, add hydrochloric acid, dilute hydrochloric acid in both the test tubes. You may not have hydrochloric acids in your home. Some home they use for cleaning the toilets, they use acids. You can use that, or otherwise you can use vinegar for doing this activity. Okay, what do you observe? And that is what we are going to see here. And you are going to get lots of effervescence. You should know you have to note down this term, what I'm telling you now. Effervescence. Effervescence, it means that there is a gas which is coming out, bubbles out like anything. Okay, like fizzing out. That is effervescence. In other words, I can say that if you take a Coke bottle, shake the Coke bottle and open it up. So what will happen? You can see the bubbles are just rushing it out like that. That is effervescence. That means the carbon dioxide which is present on the Coke or whatever soft drinks, it comes out like anything. Okay, so you can imagine that is what effervescence. Okay, what you are going to do from here this and what we are going to learn from this activity. We are going to learn that whether it is a metal carbonate or metal hydrogen carbonate, when it reacts with acid, it gives carbon dioxide gas. Carbon dioxide gas. Clear? And you can also look at this picture which is given in page number 20, figure 2.2. You learn this. There is a test tube which is given here, and this test tube is filled with calcium carbonate. Calcium carbonate is nothing but a metal carbonate. Okay, a metal carbonate. Calcium is a metal and carbonate. Okay, and when we pour hydrochloric acid inside this, and hydrochloric acid is the dilute acid, we are taking dilute acid, and immediately you see lots of bubbles of carbon dioxide comes because it is completely covered with a cork, a rubber cork. There is no way this is also be closed. Yes, there is the only way the carbon dioxide can escape is through this delivery tube. And here there is a test tube they are using. This test tube is containing calcium hydroxide. Calcium hydroxide is the lime water. Calcium hydroxide is a lime water. What is calcium oxide? Calcium oxide is a quicklime. Okay, in other words, tuna. And remember this word, we use this word, this term calcium oxide in chapter 1 There we learned we take calcium oxide and react this calcium oxide with water to give, and this is one of the exothermic reaction. Okay, calcium oxide react with water to give calcium hydroxide. This is what we learned in chapter 1. Okay, just a recap of what we learned. Okay, when we take calcium oxide, put it on a water, it gives enormous amount of heat energy along with calcium hydroxide. Okay, calcium hydroxide is the lime water. क्विक लाइम पानी में मिलाएंगे तो लाइम वाटर हो जाता है. Okay, okay, this is what happened. Let's see how this reaction takes place. Okay, when an acid reacts with metal carbonates and metal hydrogen carbonates, first of all, how an acid react with metal carbonate? An acid, when it react with metal carbonate, it gives three main products. One is the salt, water, and very importantly, carbon dioxide. Okay, and how this reaction takes place here? Hydrochloric acid, that is what we have taken, and sodium carbonate is the salt we have taken, and this is a metal carbonate. Sodium is a metal, carbonate is attached to that, so it is metal carbonate. Lots of metal carbonates we know that: sodium carbonate, potassium carbonate, aluminum carbonate, calcium carbonate, right? And these are the metal carbonates. So we can take any one of these metal carbonates. When we react with this acid, it gives salt, water, and carbon dioxide. And here is an acid. And you all know that acid is having a strong H plus ion and chlorine a negative one. Sodium carbonate, sodium is positive, and carbonate is a negative one. So always positive will go and stick with the negative. So it becomes sodium chloride. Yes, and this is the salt. And what are the other products? Water, H plus, and one of the negative of oxygen will combine form H2O, and the remaining is carbon dioxide, CO2, and this is comes out as an effervescence. Okay, effervescence is nothing but which comes out, fizzing out like anything. If you see a milk boiling, immediately it boils out and comes, right? And that is how effervescence looks like. Okay, we'll do one more example, which is given in the activity itself. We take hydrochloric acid and put some calcium carbonate in that. Calcium carbonate, we know that it is a metal carbonate. Okay, positive, negative, and this is calcium is positive and carbonate is negative. Okay, then what happened here? Calcium and chlorine combines, form calcium chloride. Calcium chloride formula is CaCl2, and you should know how this 2 comes. Remember that in 9th standard we know how to make a formula: calcium and chlorine, calcium valency 2 and chlorine valency is 1. And cross multiply that, we get CaCl2, and this is how the formula of calcium chloride comes. Okay, then what are the remaining products? You can even write just like that, because it's these two products are very common when an acid react with a metal carbonate. These two always comes. Okay, and then you need to balance this. Calcium only 1, here 1, and then chlorine 2, here is 2. You should balance this, hydrogen 2, and the rest will be balanced, right? So what we learned now, we learned that when an acid react with metal carbonates, it gives always salt, water, and carbon dioxide. Okay, what happens when an acid react with metal hydrogen carbonate? Let's see that also. In both the case, even when an acid react with metal carbonate or when an acid react with metal hydrogen carbonate, in both these you can find the same type of product like salt, water, and carbon dioxide. The same example I can write: hydrochloric acid react with sodium hydrogen carbonate, sodium hydrogen carbonate, metal hydrogen carbonate. Clear now? Okay, we write the name sodium hydrogen carbonate, and it gives the salt NaCl, sodium plus, so it becomes NaCl, and water H, one H, another H, so 2H ho jayega, so H2 and one O from here, so H2O and carbon dioxide, right? So this is how whenever there is a metal react with metal hydrogen carbonate or a metal carbonate, acid react with metal carbonates or metal hydrogen carbonate, you're going to get salt, water and carbon dioxide. Okay, now the main product from this is carbon dioxide. Okay, let's learn how to identify, how to test this. The test to identify the gas which comes out is carbon dioxide. How can we identify the gas which is coming out is a carbon dioxide? In the last class, we may have done a equation there. When an acid react with metal, it give hydrogen gas. Remember, salt plus hydrogen gas. And how do we tested that? We burn a matchstick and keep it on the mouth of the test tube, and we heard a pop sound. That pop sound indicates the gas comes out is a hydrogen gas. Okay, now how to test this carbon dioxide? It's a simple way. What we do is, even in the activity, you remember that there is an the test tube which is given here. This test tube containing calcium hydroxide. And what is calcium hydroxide? Yes, it is the lime water. When we pass this carbon dioxide, the carbon dioxide which is coming out from this metal carbonate or metal hydrogen carbonate, what we do is we pass that gas through calcium hydroxide. When we do so, we get calcium carbonate. That means the color of the calcium hydroxide is nothing but a normal water-like thing, water-like color. There is no color for that. But when we pass this carbon dioxide into this calcium hydroxide, the color turn into milky. Okay, the color of calcium hydroxide is turned into milky. What it means? It changes to calcium carbonate. So calcium is positive, right? And carbon dioxide, you all know that it's a gas. So Ca, yes, CO3, and one from here. The remaining is H2O. Okay, this is what happened when we pass carbon dioxide into calcium hydroxide. The color of calcium hydroxide turn into milky. That means the product comes as a calcium carbonate. Okay, this is the one thing, and this calcium carbonate is insoluble in water. That means if you keep that solution for some time, you can see all these calcium carbonate comes down and the test tube and settle at the bottom. Remember that suspension? In suspension, if you put some chalk powder, all the chalk powder comes down and settle at the bottom. Like that, if you leave it for some time, all the calcium carbonate comes down and settle at the bottom because it is insoluble in water. They won't soluble. Okay, there is a question arise. What happens when we add more and more carbon dioxide into calcium hydroxide? Okay, you all know that uh, when calcium, whenever there is a when calcium hydroxide, when carbon dioxide is passed through calcium hydroxide, we got calcium carbonate. Okay, now it becomes calcium carbonate, CaCO3. What happens when we pass more amount of carbon dioxide into it, and this calcium carbonate is already in the water? So when we pass more carbon dioxide continuously on it, okay, so what happens? It becomes, yes, calcium hydrogen carbonate. Okay, we get a calcium hydrogen carbonate. The name is totally changed. And this calcium hydrogen carbonate, which is formed when we add excess carbon dioxide in calcium carbonate, and this is actually a soluble, it's easily soluble in water. That means what? If you add more and more carbon dioxide into calcium carbonate, the color of milky turn to the normal color. Okay, normally it looks like a normal water color. Okay, you all understand now? Yes, I want you to go through this, which is given in your book. Okay, here it is. Calcium hydroxide, aqueous, it means a liquid. When we pass carbon dioxide, which is a gas, it turns into a calcium carbonate. That means it's a white precipitate. Precipitate, all the precipitate, they never soluble in water. It become a insoluble solids. Insoluble solids they form. Okay, this is what the water. Then what happens when we pass more and more carbon dioxide in calcium carbonate, we get calcium hydrogen carbonate, and that is soluble in water. Okay, you can see limestone, chalk, marble, all these are the different forms of calcium carbonate. Okay, in all these things you can find only calcium carbonate. And all metal carbonates and hydrogen carbonates, that means metal carbonate and metal hydrogen carbonates, when it reacts with acid to give a corresponding salt, carbon dioxide and water. So the summarize of all reaction is metal carbonate or metal hydrogen carbonate, when it react with acid, it gives salt, carbon dioxide and water. Okay, so I hope you all understand this topic, and we learned a very simple topic today. And what you should do is go to your and today the work is read 2.1.3 completely, and I hope yesterday I gave you a work to read the complete pages from page number 17 to page number 19. No, page number 20. Okay, up to here. Hope you all done your work, and I want you to keep reading, and any doubts please ask me in my personal number. Thank you, student. Have a wonderful day.